Good morning, everyone, or I guess good afternoon, as always. I always want to say it's morning, even though it's 1 o'clock, but that's all right. So today we're starting chapter 6, as promised, and I think I've kind of hinted at the fact, but this chapter is my favorite, probably because this is the kind of research that I do, but but we're going to start this chapter, and we have lots of time before our midterm to get working through these concepts. So you're going to find that we're going to talk about quite a few different and diverse different types of learning. So we're going to break them down into different sections. So let's start with our general definition of learning. So learning is going to be an enduring or durable change in behavior or mental processes due to experience. That's quite wordy, and that's actually a combination of quite a few different definitions that I've seen over the years for learning. But the part that we want to focus on is that it's going to be relatively permanent, something that's going to last. That's why it's enduring or it's durable, because when you learn something, you know it for a certain amount of time. It's going to cause a change in behavior. We might be able to say that it's a change in mental processes or a change in knowledge, but that's a lot harder to show. In practice, when you're studying learning, you almost always end up sort of monitoring behavior and looking at how behavior is changing. So we want to study changes in behavior because you can't tell if someone knows something unless they're acting differently based on that information. So that's more of a practical change. And then we want to know that our learning is going to be occurring due to some of the interactions that we have with the environment. So we've talked about experience as us interacting with our environment, encountering different stimuli, and then learning about what it is or what comes from interacting with those stimuli. So all of these components are part of our definition of learning. All right. And so, as I said, we're going to talk about a bunch of different kinds of learning. So I'm going to talk about 4 types of learning. I don't think our textbook separates out the first type of learning as a separate thing, but I find it useful to kind of establish our starting point. So we're going to start with event-alone learning, and that's going to include habituation and sensitization. We're also going to have event-event learning, which involves classical or Pavlovian conditioning. And then we're going to have behavior event learning, which would be instrumental or operant conditioning. You're going to find that most of these have multiple different names, which just makes it all the more better. And then we'll wrap up with social learning. And so each of these are going to be something we go into in a lot more detail. So right now, the titles and the names don't necessarily mean anything to you, but this is our roadmap for the chapter. And before we start with any of those behaviors, we're actually going to begin with unlearned behaviors. So things that we do that aren't occurring because we've learned them. So when we're born with something that we know how to do it from birth, we might say that it's innate, something that is inborn or naturally occurring, something that we don't have to learn through experience. And so for us, innate is usually going to mean that there's a genetic component. So when we were talking about things that produce behavior, we said that there was that genetic component and the environmental component, and they're both going to interact to produce behavior. It's kind of like the nature versus nurture debate, where you can have a little bit of nature, which is your genetics, and a little bit of nurture, which is the environment in which you're raised, and that produces your net behavior at the end. So same basic idea here. So if we're saying that something is innate, we're saying that it's all nature, it's all from our genes. And so we have no need for learning if we don't actually have an environmental component, if it's all genetic. So those unlearned behaviors, most of the time we'll call them reflexes. I do want to take a moment because there's an unfortunate way that the terminology, especially around learning, kind of overlaps with a bunch of other stuff and leads to a little bit of confusion. So sometimes you'll see a reflex referred to as some kind of stimulus response, basically a behavior made in response to the presence of a stimulus. which is either learned or innate and indicates that the behavior has happened automatically. So you might see a reflex as something, an automatic response that you have learned to do. And that's technically accurate by the definition because it happens automatically, but I'm going to be trying to use reflexes specifically to describe something that is innate and that you're born with, something that has that genetic component. And if we're talking about things that are learned but occur automatically, that's when we're talking about classical conditioning, which will be sort of our second section of this chapter. So when we're talking about reflexes, we're going to be specifying those innate reflexes, the things that we do naturally without having to learn about them. And then if we wanted to think about some examples of these, we have quite a few different reflexes, things that we don't even realize that we do because of these naturally occurring behaviors. But things like touching a hot stove, that really quick withdrawal, we talked about it as a reflex arc, that would fall under this category. And that's because it's something that you do without any conscious thought involved. So it's an automatic process. When we're younger, we actually have a lot more of these, and they kind of disappear as we get older. So for infants, they have a natural grasping response. That's why if you put your hand or your finger in an infant's hand, they'll typically close their hand around it. It's a reflex that they do automatically. They also have a reflex where if their face is covered, say by a blanket or something, they're going to push downward to try and dislodge the thing that's covering their face. There's lots of really neat reflexes that can be had there. And we can have much more complex sets of behavior. If you've ever gone into any of the learning literature, there's things like fixed action patterns, where you can have sort of strings of behaviors that get put together, and they occur from start to finish automatically without any conscious involvement. And those are just really neat. I usually talk about them as they relate to, say, geese rolling eggs. So geese have this natural behavioral pattern where if they see an object outside of their nest, they will stand up, extend their neck, and roll that object back towards the nest. And if you interrupt that fixed action pattern, it doesn't matter. The geese are going to continue, even if you remove the egg, or even if you sort of relocate them, they're going to still go through those motions because it's a full string of events that happen without any conscious input. So that's a really neat one, and it's if you look at some of the literature from that, they've tried to see how far they can push those behaviors. And so fixed action patterns are neat in that they sometimes occur more extremely, so you can have a more intense version if your stimulus is more intense. So if you have an egg that's bigger or more colorful or whatever than normal, then they might be quicker to do that behavior, but it's always going to follow the same pattern. So it's just a little bit of a tangent about how some of these innate behaviors can be a little bit more complex than what we might think of. Okay, and so those are things that we don't learn. Now let's actually get into the stuff that's relevant for the chapter, which is learning. And our first type of learning, as I said, is event-alone learning. And we're going to talk about habituation, and then usually when you talk about habituation, you also talk about sensitization, because it's sort of the opposite side of the coin to habituation. And so we'll chat about that in just a second. But first I want to explain why it's event-alone learning. And you'll see, as you kind of already noticed, on our roadmap, we have event-alone, event-event, and then behavior-event. And it's just talking about what kinds of actions, what's going on that leads to these behaviors. So if we have event-event, we're learning an association between two different events. Here, with event alone, we just have a single stimulus, a single event that's going to lead to this behavior. And so this is why habituation isn't necessarily always included in texts, because it's a change in behavior from just being exposed to a single stimulus over and over again. And so some people don't necessarily call that complex enough to be learning, but that's besides the point. We're going to discuss it anyways. So for our definition, habituation is a process by which we respond less strongly over time to a repeated stimulus. And so if you have the same thing happen over and over and over again, your behavioral response, your reaction to that stimulus would be lesser and lesser. So this could be, maybe you have, I like the example of a sibling that likes to jump out at you from behind the bathroom door. They think it's hilarious to startle you, and so they're going to jump out from behind that door, and you're going to be startled the first time. But then the next time you go to the bathroom, they do it again, and again, and again, and then you learn to expect it, and you have less of a behavioral response to it. So for here in learning, habituation is just that reduction in your behavioral response, less of a reaction to a stimulus that keeps happening. And this term, habituation, might be familiar because we actually discussed habituation when it came to sensory habituation back in that sensation and perception chapter. But here, we're sort of making that distinction where it's sensory habituation and then habituation as it relates to learning. So with the learning side of thing, it's a simple form of learning where we see a reduction in behavior. With our sensory habituation, that's when you are exposed to the same sound or the same smell or the same image, and over time you paid less attention to it. So that was the idea of going nose blind, where you were in a situation where there was a smell in the air, but because the smell isn't changing, you would eventually ignore it or wouldn't notice it anymore. So sensory habituation is that sort of noticing it less. There's still the activation, the smell is still there, it's still registering, but you're not paying attention to it. But with the learning habituation, that's that reduced responding to a stimulus. And so this is just a little bit of interesting information how habituation has been studied. So the base biological mechanism of habituation was originally studied by Eric Kandel, and he studied it in a sea slug. So this is Aplysia, specifically Aplysia californicus is the one that they work with. And these are just giant sea slugs. The picture makes them even less appealing, but if you see them in real life, they're awful. And they're a lot larger than you would ever want them to be. So they're a couple of centimeters, but you can actually have them up to, like some of the bigger ones are almost a foot long, which just I did not need to know, but now that I know, you also have to know. And so the way that these guys work is they're a fairly simple organism. They're pretty easy to maintain in a lab, which is why they did a lot of research with them. But you'll notice on their back, they have a slit that's labeled as a gill. And that's basically a portion on their back that will open up and allow their gills to expose out to water. And so the way that they do this is if it's calm and it's in sort of a safe environment, they'll open that spot and then they'll put out feelers into the water, their gills, in order to get better air exchange. So it helps them breathe, and it's more efficient if they can have them out in the open. However, if they're stimulated, say it gets really wavy or there's stuff moving around or there's a predator nearby, they can retract those gills back inside and close off again to protect them. So this Dr. Kandel figured out that if you poke those gills, they have a very quick reflexive sort of retraction. So they will immediately pull back their gills. And then so if you let them relax again, they'll put them back out, and then you can poke them again and they'll pull them back in. And so he figured out that if you do this over and over and over again, the reaction starts to change. So they don't pull in as quickly, and eventually they don't pull their gills in all the way. So it would start to be just like a slower withdrawal all the way in, and then maybe they would slowly go half in, and then maybe they just kind of flinch a little bit but leave it, and then eventually there's no response at all. So that's a perfect example of this habituation where they got used to that the pressure of being poked and no longer had that response. Their behavior changed. And then, of course, as I said, if we're going to talk about habituation, we talk about the other side of that pattern where we have sensitization. And so instead of a decrease in responding, sensitization is an increase in the strength of a response to a repeated stimulus. So if we go back to that example of your sibling hiding behind the door, maybe you're like me and you're someone who really hates being startled and you don't react well to surprises. So the first time it happens, you get really startled. And then from there on, you're kind of waiting for it to happen again. And so the next time they jump out at you, you actually have an even bigger response because you were braced for it and it's still scary. And so over time, you're going to have more and more of a violent reaction because you've been sensitized to that particular stimulus. And so from this example, we can have that sort of internal state of arousal, that emotional activation where you're braced for it, you're tensed up and waiting for it, that actually makes your response worse. So there can be different forces, things going on internally, or even things going on in your environment that can make you a lot more likely to react to a particular stimulus. And then if we want to talk about, well, what makes something habituate or sensitize? What's the difference, and how do we decide which one happens? And the answer is you can have either to any stimulus. So the sibling jumping out from behind the door example shows you that you can be either habituated or sensitized to that exact same scenario. But there are some things that will bias you sort of one way or the other. As I said, internal state is a big one. The environment is another big one. But if we wanted to look at general rules, habituation tends to be highly specific. So if your sibling only jumps out at you from behind the bathroom door, then you're going to be a lot more likely to get used to that and know that the bathroom is the unsafe place. So you're expecting it and it's not a big deal. But you're fine everywhere else, so you habituate and don't react anymore. But with sensitization, it's less specific. So maybe they jump out not just from behind the bathroom door, but also from a closet door, and also from the kitchen, and also from somewhere else. So having those different environments where it happens, same basic stimulus, someone appearing suddenly, but that extra sort of change to it makes you a lot more likely to be sensitized to it instead of desensitized. And that's not a hard and fast rule, that's just sort of a general overall. Okay, so that was our event alone learning. So a single stimulus causing a change in behavior over time. Now we're going to move on into event learning. And so this is called classical conditioning or Pavlovian conditioning. I typically stick with classical conditioning, but you're going to see the terms used pretty much interchangeably. Different texts have different preferences, but both are accurate. But the reason why it's called Pavlovian conditioning, in addition to the classical conditioning, is because it was first described by Ivan Pavlov. And so if you don't know the story about Pavlov, he was a prominent Russian researcher, and in fact he was studying digestion. So he was doing research on enzymes produced in the process of digestion. And so he had a lab set up where he had dogs, and they had cannulas, basically tubes that allowed him to collect their saliva in order to measure the enzymes. And he also figured out that those enzymes were something that he could sort of refine and package and then sell for a profit. So that's what his lab was set up to do, was study digestion. However, he started to realize that every morning when his grad students came into the lab, there was a bell on the door. And so when they'd come in, they'd ring that bell. And they were coming in specifically to take care of the lab, to feed the dogs, to get everything set up for the day. But he noticed that the levels of saliva for the dogs was actually rising even before they were given food. So usually dogs salivate because they've been given food. So it's part of that food process. So it's a natural response to getting food. But he was noticing that they were salivating with no food simply when they heard that door open and ring that bell. And so that's that starting point where he started to realize that these dogs were making associations, making learned connections between two events, ringing that bell and then getting food. And we get to see their physical response to the food sort of shift over and transfer over and apply to the bell's presence as well. And so that's what we're going to be looking at here, and we're going to talk about quite a bit of terminology just to understand the process of what's going on here. So as per usual, our standard definition, so our classical or Pavlovian conditioning is a form of learning where we start with a neutral stimulus. That bell above the door had no meaning when we started, but it's going to come to signal the occurrence of a second stimulus, the delivery of food. And so you're learning an association between what was once a neutral stimulus and a second stimulus that comes later. And so I've already used a couple of terms that might be useful to know about here. So when I've talked about eliciting, so bringing about a particular response, we usually just call it eliciting. So if we were saying that the dog has learned that the bell means they're going to get food, the bell might elicit salivation, which is that response to getting food, but also now to hearing that bell. A stimulus, that could literally be anything in our environment. It has to be something that we can detect, something that we would be able to measure for our research, and hopefully that we can have evoke some kind of response or behavior. So we might have a neutral stimulus that will eventually come to elicit a response, but if you're doing classical conditioning, stimuli that can't be learned about or that aren't useful aren't necessarily considered. So we have some of these caveats for what we mean here for a stimulus, whereas it's sort of a general term that can refer to lots of things. We've already sort of mentioned the fact that we can have associations between those stimuli. So an association is just a learned relationship between two different stimuli. And then acquisition, that's when we're referring about the time when we're acquiring an association. So while we're learning to associate those two stimuli, that's the period of acquisition. Once we've learned about that association, then we're out of that period of acquisition, we're in that learned state. But acquisition is sort of that early part while we're still in the process of learning. So these are all important terms that I find a lot of texts will just sort of throw at you and assume that you know or can figure out from context, but it is also very helpful to just have them in one place to look at. Okay, so that's general talking type terms, but of course when we're coming into classical conditioning and the setup, we're going to have terms that are specific to this particular arrangement. That's one of the parts that people find hardest about this chapter, is the fact that it's fairly terminology heavy. And I've taken this into account because I find that people do a lot better if I go over the terms multiple times, if we have multiple examples, if we have lots of different images, and especially if we revisit topics, especially in between classes. So you're probably going to get tired of this stuff, but when you come to an exam, it's going to help because hopefully this will start being a little bit more of an automatic understanding instead of something that you just blindly memorize. That's the goal anyways. But with classical conditioning, we have our set of terms. So we can talk about first our unconditioned concepts here. So unconditioned just means that it's something that we don't have to learn about. So if it's classical conditioning, it's a type of learning. Conditioning is just meaning learning. So unconditioned means it's an unlearned, and then we can have a stimulus or a response. So a stimulus is the thing that ends up eliciting a response, and then the response is the behavior that's produced by being exposed to that stimulus. Just some groundwork on our terms here. But if we put it together, we can have an unconditioned stimulus, which is usually shortened to a US. There's also an annoying tendency between some texts to use UCS because it's unconditioned. I mostly find that annoying, but you might see some texts use it and some don't. I'm just making you aware of it. If you see UCS, that means the same thing. But this unconditioned stimulus is going to be some kind of biologically significant stimulus that already has an association or a response associated with it. So this is that idea of the dog's getting food. That would be an unconditioned stimulus. And that's because when dogs are given food, they naturally start to salivate. So that's a response that occurs naturally to that particular stimulus. We could also have something like pain or a loud noise, which would elicit a startle response. There are lots and lots of different kinds of unconditioned stimuli. And then, of course, we have the unconditioned response, which is the response that's naturally associated with that unconditioned stimulus. So this is the behavior or the action that follows after you've been exposed to that unconditioned stimulus. And again, I'm going with UR for unconditioned response. Sometimes we see UCR for unconditioned response. I just, again, find it really annoying because there's only 2 words, so there should not be 3 letters in the acronym. But this would be our salivation. So a dog would salivate when exposed to food. So that exposure to food would be the unconditioned stimulus, and the salivation would be that unconditioned response. So they don't have to learn anything about that stimulus in order to produce that response. There's no learning here, hence unconditioned. Oh, yeah.
Can you please demonstrate the classical conditioning in just a single line, like a 1-line definition?
This one?
Yeah.
So that's when you, because it's going to make a lot more sense once we go through all the definitions, but okay. Okay, so that's our setup. It's the naturally occurring stuff, the things you don't have to learn about. That's what exists prematurely. That's at the start of our session. We then also want to bring in this neutral stimulus. I don't usually see it shortened to NS, but we're putting it there to be consistent with all the others. This neutral stimulus starts neutral, but doesn't stay neutral. We will eventually be learning something about this stimulus. We will learn to associate it with other things, but at the beginning, this is just a stimulus that does not naturally elicit any kind of response, or at least not a response that's relevant to our experiment. So this could be something like a tone or a chime or a bell. You can even have weird things like exposure to a block of color, all sorts of things that can happen that we don't necessarily think anything of. So it should be at least a little bit distinctive so that we know that it's happening, but we don't have any preconceived notions about it. We don't know anything about this stimulus to begin with. And so eventually that neutral stimulus is going to become what we call a conditioned stimulus. And so again, if conditioning is a process of learning, a conditioned stimulus is a stimulus that we have learned about. So our CS is the neutral stimulus once we have learned an association. So our previously neutral stimulus will come to elicit some kind of conditioned response. So it's still something that started neutral. It's still a tone or a chime or a bell or a color or whatever we want. But now it's going to lead to a conditioned response. And then our conditioned response, or CR, is a learned response that occurs due to some kind of stimulus in our environment. So that would be, say, the original thing that we were producing, our unconditioned response, was salivating to the presence of food or being startled by something that's really loud. This conditioned response is going to be the same response, but it's now elicited by something else that's been paired with it. So that might not make a whole lot of sense quite yet, and that is perfectly understandable. I have at least 2 separate examples that I want to walk us through to understand what's going on here, because this is a lot of terminology to throw at you at once. So let's start off with an example, and we're going to stick with the original Pavlov's example. We're going to have a bell, and we're going to have food. So we have an so we're going to start with, the presentation of the food. We don't really care about the bell quite yet. When we start, the dogs were being given food. That's the unconditioned stimulus. When they're given food, they salivate. That is the unconditioned response. They salivate naturally when they get food. They don't have to learn anything about it, hence unconditioned. But we want to introduce this classical conditioning. We want these dogs to learn something about this bell. So we're going to start off with what is originally a neutral stimulus that is going to become a conditioned stimulus. And that's our bell here. So we can have that bell, so we'll ring the bell, then we'll give the dogs food, and they're salivating because they've been given food. So if we wanted to check, okay, after we've done this once, we ring the bell, we give them food, we notice that they're salivating. If we only do it once, they haven't necessarily learned that the bell is linked or associated with the food. So if we do a test trial after only a single pairing of our conditioned stimulus and the unconditioned stimulus, we're going to get no response. we don't end up with a conditioned response yet because we're still in that acquisition phase. We're still learning about the association between our two stimuli. So the dogs don't necessarily know anything here. So we would say that if they haven't learned anything yet, then this is probably still just a neutral stimulus. They haven't learned yet, it's not conditioned yet, so the bell, they haven't learned anything yet. Okay, but let's do it multiple times. Instead of just once, let's do it twice a day, every day for a week. Or let's do it 20 times, because that's what's on the slide. So we will ring the bell, give the dog food, and then they'll be salivating. And then we ring the bell, we give them food, they salivate. Ring the bell, food, salivate, on and on and on. So hopefully during this process, they'll be acquiring that association between the ringing the bell and giving the food. They should learn an association between the two. And then if we want to test what they've learned about our bell, about our stimulus, we can then ring the bell and see what they do. And so if after 20 pairings, if they've acquired this association, ringing the bell should lead to the dog salivating, even if you haven't given them food yet, because they've learned that the bell is paired with food, and so it means that food is coming. So they're going to have the same response to the bell that they would to the food because they've associated the bell and the food. So we now have salivation, and it's a conditioned response because it wasn't elicited just by the presence of the food, but now it's been elicited by the presence of the bell. So one of the things you're going to want to watch for is what specifically is leading to our response. Because as I said, our unconditioned response and our conditioned response, in both cases here, it was salivation. So the dog was salivating. But why were they salivating? At first, they were only salivating because they were given food. That's when it's an unconditioned response. There's no learning involved, it's just the food, they automatically do that. But when they start salivating because of the bell, because of something they've learned about that conditioned stimulus, that's when we call it a conditioned response. So it's still salivation, but what's changed is what's causing it to happen. So that's going to be your distinguishing factor there. And so if we want a slightly different diagram that we can use for this, we can have this broken down into our before, during, and after conditioning. So here they're using a tone instead of a bell. Same idea. It's a sound. So before conditioning, the tone, that's going to be our neutral stimulus at that point. It doesn't produce any kind of response because the dog hasn't learned anything about it. If we give them the food with nothing else, they're going to have that unconditioned response. They're going to salivate because food is a great unconditioned stimulus. Then during the conditioning, you're going to pair them. You're going to present both the conditioned stimulus, that tone, and the unconditioned stimulus, the food, and you're going to get an unconditioned response. We're saying unconditioned at this point because while they're learning, it's still mostly driven by the presence of the food, that unconditioned stimulus. And then after conditioning, if we test it and only present them with the conditioned stimulus, the tone that was previously neutral, if it elicits a conditioned response, if they salivate to that tone, then we know that the tone is now a conditioned stimulus, and the salivation is, in that instance, a conditioned response. All right, and then I had a couple other diagrams that show the exact same information, just showing sort of the relationship between them. So this is showing relationships as lines. So this is just a slightly different way to frame this if the other examples weren't quite working for you. But hopefully we're starting to make sense, so we won't spend too long here. So before conditioning, we have our neutral stimulus that comes beforehand. Then we have our unconditioned stimulus, and the unconditioned stimulus leads right into an unconditioned response. Then during conditioning, while we're learning that association, they're going to be presented together or close together in time if we're doing it right. And so we start making that green line, that association between a neutral stimulus and that unconditioned stimulus. And we're still going to get that unconditioned response. And then eventually, The neutral stimulus would be called a conditioned stimulus because of the association that's formed. And now when we have that conditioned stimulus presented, we're going to get a conditioned response. And this diagram does another good job of showing that the terminology tends to be inconsistent between locations. This is from a different text that uses unconditioned or unconditional and conditional instead of conditioned and unconditioned. And that's actually a translation error, just a small unique fact. And it's because it was originally done in Russian, and then there was something about translating it to English where it's supposed to be conditional and unconditional, but the literature has said conditioned and unconditioned for decades at this point. So you can use either, but my preference is conditioned and unconditioned because that's what most things still have. Lots of alternative names for things, but at least the front part of the words are always the same. Okay, so that is the process of our classical conditioning. So that's going from a previously neutral stimulus that we then pair with an unconditioned stimulus, and it's going to eventually lead to a new conditioned response. So that is our setup there. And so if we wanted to talk more about our unconditioned stimulus, we can actually divide it into two broad categories. We've been talking about being given food. That would be what is called an appetitive stimulus, or a stimulus that the animal finds pleasant. So this could be food, but it could also be something like play or attention or interaction. Those would all be considered appetitive. You can also do conditioning with aversive stimuli, and this is when the stimulus is something the animal finds unpleasant. So maybe you have a loud sound or darkness. A lot of older studies on conditioning looked at responses to pain, simply because it was a very intense stimulus that produced very fast learning. But as we've advanced with our understanding of ethics and all of our rules and guidelines, we see a lot less pain research unless it's specifically required for understanding pain. But we can have either appetitive or aversive conditioning. And we're going to find that this kind of relates to some of the things that we talk about in our next topic, which is the operant conditioning, where we can have things that increase or decrease a behavior. But we'll see that connection as we move on. We're going to keep talking about this unconditioned stimulus. And we can talk about some of the things that make an unconditioned stimulus a good candidate to be an unconditioned stimulus. So as we said, it can be either sort of appetitive or aversive, but in order to be effective, whether it's sort of good or bad, it should also evoke some kind of strong bodily response. So it should be something that we should be able to observe and something that's going to have something fairly strong. The idea is the more intense the unconditioned stimulus, the easier it is to produce a conditioned response through learning. But of course, that only applies up to a certain limit. If something is too intense, we can see situations where learning can't occur or is interfered with and other weird stuff. But for the most part, the more intense an unconditioned stimulus, the better. And things that are sort of biologically relevant seem to work really well. So most of what we'll talk about will be things like sounds or food or something in that line, because it has a pretty natural response that's easy to observe. Okay. Perfect. So the next thing I want to talk about are types of CSUS pairings. So I've mentioned the fact that we have our conditioned stimulus and our unconditioned stimulus, our bell and our food, and we're going to be presenting them at about the same time. But we can start varying the pattern in which we present them. So there are 5 sort of subtypes of pairings that we can talk about. Some are going to be more or less effective. And again, I have sort of written responses, but I also have visuals on the slides that follow. So we'll do a little bit of flipping back and forth between them. But if we start with our short delayed conditioning, this is when our unconditioned stimulus, that food, is going to be presented just after the CS has started. and specifically while the CS is still going on. So if you had a tone that was playing, you would have the tone start, and then shortly after that you would deliver a plate of food. There's only, say, a second or 2 or 3 seconds between the start of the tone and the delivery of the food, and ideally the tone would still be going on while the food is delivered. And so if we wanted to do a visual of that, we could have it set up like this. So in this case, they're looking at an association between lightning and the sound of thunder. So they wanted us to, or I guess we don't need to go into the specifics. The visuals are fine. So overlap between them and a very short delay between the starts. And then you can kind of see down here for long delay, it would be something very similar, except that delay at the beginning is longer. And whenever we ask about these things, if it's something that's, say, less than 10 seconds, that would fall under the short category, and then arbitrarily we'd say long delay would be sort of more than 10 seconds. If I ask a question about this, I will make it very obvious. Something less than 10 seconds and then something probably like a minute or so, just so that you can tell the difference. This is one of those things that would be cleared up in an article using an operational definition, where you would tell them what you are calling this, short or long, based on your own interests. But just a little bit of a explanation there. And so then the long delayed conditioning is that unconditioned stimulus would start after the conditioned stimulus has been on for a while. So that was that longer delay before the delivery of the food. So the tone is on for a long time, and then the food is delivered. And so our short delay conditioning, because the tone would start and very, very soon after the food is delivered, that has a very short sort of separation of those two events in time. And that actually leads to a stronger association being formed. So we actually find that in most situations, our short delayed conditioning is going to be the most effective method of learning an association. So the most effective kind of acquisition is that short delay conditioning. And it's just because they're located very close together in time. So there's sort of a temporal overlap or almost overlap. The next one after the short and the long delays are trace conditioning. And trace conditioning happens when our conditioned stimulus begins and ends before the unconditioned stimulus is presented. So this would be where our tone would go off turn on and then turn off again, and then after it has turned off, the food would be delivered. So there's a gap between the two stimuli. And so again, with an image here, we could have either a really long gap or even a couple of seconds of a gap. And we might specify sort of long or short in an operational definition, but there is no overlap between the two. So that's what's specified here. Simultaneous conditioning is a nice, easy one, and that's when you have both presented at the exact same time. So your tone would go off while the dog is getting food. So they are both going to overlap entirely. So they start at the same time, and that is simultaneous conditioning. So that one's nice and easy. And then our last one is backward conditioning. And you're going to notice why it's called that right away, and that's because it's going in the opposite direction. And so if I hop up to my definition, so I make sure I say it right, this is our unconditioned stimulus occurring before the conditioned stimulus. So this would be the dog getting food, and then after they've had the food, then the tone sounds. And as you can probably imagine, this one is a lot harder to learn an association, because after the food thing has happened, most animals don't care about it anymore. So anything new that happens doesn't get backwards associated. So backwards conditioning is not the most effective method of conditioning. All right. And then the last thing that I wanted to talk about was how we enhance acquisition. So I've already mentioned the fact that using that short delayed pairing or short delayed conditioning is the best way to get that association learned. Another way to enhance our acquisition or make us learn that association better is to have multiple pairings. So if you have lots and lots of exposures to our conditioned stimulus and the unconditioned stimulus in whatever arrangement we choose, you're going to have better learning with more trials. There is sort of a caveat to this where there are some special cases where we can get one trial learning. So sometimes very intense aversive stimuli can produce one trial learning. So this would be something like food poisoning, or I'm trying to think of the correct term for that, but it's when you acquire an aversion to food. I always use the example of I have a food aversion for apple juice because when I was a kid, I drank way too much apple juice that had sat out in a hot car all day, and I immediately threw up. And single trial learning, I have never intentionally drank apple juice after that because anytime I think of it, it just makes me feel gross. So that would be a very intense aversive stimulus after only a single pairing, and I've learned something about it. And then we've probably figured this out, but if the time interval between our CS and the US is short, if they're very close together in time, learning is going to be a lot better, which is why our short delayed pairing is fairly effective. And so we'll leave it there. We'll start talking about other aspects of this classical conditioning in our next class on Friday.